Right, so in this problem what we're trying to do is determine the overall reaction enthalpy for this reaction listed here at the top. And we're going to determine that by using the data given for these reactions here. The basic idea is what we're going to do is add these reactions together in a way that when we add them together gives us the overall reaction. And then once we figure that out, we're going to add the enthalpies for those reactions together in the same way. So let's take a look at what we've got here. In the overall reaction, we've got nitrogen monoxide reacting with oxygen to generate NO2. So if we look at the reactions down here, we'll notice that the first reaction has nitrogen monoxide as a reactant, and that's what we want. So we're going to take reaction 1 here, and that's going to be NO plus O3, which is ozone, yielding NO2 plus O2. All right, and then we're going to take a look at what else we need. So if we go back up here to the top, we see that we need oxygen, atomic oxygen, as a reactant. So we look down here at the bottom, we see that, well, reaction 3 here has atomic oxygen as a product. So we want to reverse that, is what we want to do. So what we're going to do is we're going to reverse that. And when we reverse that reaction, that's going to give us atomic oxygen as a reactant. It's also going to change the sign of delta H for that reaction. So let's go ahead and do that. So we're going to take atomic oxygen generating O2. All right. Now we reverse that, so we're going to come back to that. The other thing we'll need to notice is that in our overall reaction, there's only one atom of oxygen. So what we're going to do is we're going to multiply that reaction by 1/2 to get us 1 oxygen there. And we're going to do the same thing to the reaction enthalpy when we add things together. All right. So that's what we've got right now. All right, and then we're going to notice that we have, at this point, we have some things that we don't want in our reaction. We've got ozone, which is not in the overall reaction here. We need to get rid of that. We've also got O2 in the overall reaction. We need to get rid of that. And we'll also note that we've got this 1/2 O2 down here at the bottom. So how are we going to do that? So if we take this reaction 3, okay, and we reverse that, and bear with me for a second, what we're going to do is reverse that and make O3 a product. And we're going to add these together in a minute. So we're going to just take that 1.5 O2 to generate O3. All right. So now let's add these together the way I've written them. Okay. And this really kind of takes practice to be able to see exactly how you're going to add and subtract and reverse these together to get the overall reaction. What we're going to note is I'm just going to write everything out and then we'll do a cancellation. So I've got nitrogen monoxide plus ozone from the first reaction. All right. And then from the second reaction, I've got 1/2 times 2O, of course, which just amounts to a single oxygen. Okay. And then the third reaction, I've got 1.5O2. All right. So we're going to add that. Those are all the reactants that we've added together for all of these reactions. And now what we're going to do is take a look at the products. So in the first reaction, I've got NO2 plus O2. All right, in the second reaction, I've got 1/2 O2. Okay, and then in the third reaction, I've got ozone. All right, so let's take a look at this. Let me rewrite it after I kind of add things together a little bit better. So now I've got NO plus ozone plus the 1/2 times 2 just gives me a single oxygen, plus 1.5 O2 generates NO2. And so now I'm adding O2 and 1/2 O2 together, so that's 1.5 O2. And then ozone. All right, so we've got this. So let's take a look at what we've got here. So you'll notice that we've got ozone on both sides of the reaction, right there and there, and so that means really in this reaction nothing happened to it, so we're just going to cancel that out since it's on both sides. We're going to cancel that out. You'll notice also that we've got 1.5 O2 and 1.5 O2 on both sides, and they're going to cancel out too. So we just do that, and this is going to, when we add it all together now, after we remove that, we've got NO plus O, because we canceled out the O3 and the O2, yielding NO2, and that's it, because everything else cancels out. And that is exactly what we wanted for our overall reaction. So we found the combination that adds together that gives us the overall reaction. So now we're going to take a look at the enthalpies. All right, so let's just write these in again. So the enthalpy for reaction 1 was delta H equals negative 198.9 kilojoules. All right. For reaction 2, okay, so then for this reaction here, all right, which was reaction 3, we multiplied that by 1/2 and we reversed it. So that means that what we're going to do is we're going to take for that reaction, let's just label these, for reaction, for this one, what we're going to do is we're going to take 1/2 times delta H for reaction 3, and because we reversed it, we're going to change the sign, and so that means it's going to be negative 495 kilojoules divided by 2. Again, we multiplied it by 1/2 and we changed the sign from positive to negative. And then for the third reaction here, all right, what we did was we simply reversed the reaction here. And so that means that for this one, it's just going to be negative delta H for reaction 2, which was 142.3 kilojoules. All right, so now we can go ahead and we're just going to go ahead and get the overall by adding those together. So delta H for the overall reaction is going to be negative 198.9 plus negative 495.0 over 2 right, which is 247.5 plus 142.3. All right, and so we add all those together, we get our result of negative 304.1 kilojoules. So again, these kinds of problems take a little bit of practice because you have to sit down and kind of realize how you have to add them together. The thing to keep in mind is that you want to arrange the reactions, either reversing them or multiplying them by a factor so you get the same quantities, stoichiometric amounts of the particular elements on the appropriate sides of the reactions, reactants and products. So I hope that is clear. Certainly if you have any questions, just let me know.